What if we need to multiply powers with the same base? There is a rule that we can use anytime we have this need, but first let's make sure we understand the components of powers. The number or letter to the bottom left is called the base, and the number or letter on the top right is called the exponent. The exponent tells us how many times we use the base as a factor. Now that we know this, let's check out a problem. What is r to the third power times r to the fifth power? Well, r to the third power means we use the base r as a factor 3 times, so we can rewrite it as r times r times r. And r to the fifth power is r times r times r times r times r. We need to multiply these two expressions together, and if we look very closely, we realize that we have used r as a factor 1, 2, 3, 4, 5, 6, 7, 8 times. So this expression is r to the 8th power. So we know that r to the third power times r to the fifth power is r to the 8th power. But did you notice that 3 plus 5 is equal to 8? We found our rule. R to the third power times r to the fifth power is equal to r to the 3 plus 5, which is r to the 8th power. So, to multiply powers with the same base, add their exponents. Let's try another problem. What is s to the fifth power times s to the sixth power? Let's use our rule. We see we have the same base s, so we can add the exponents. 5 plus 6 is equal to 11, so s to the fifth power times s to the sixth power is equal to s to the 11th power. Let's try another problem. What is t to the second power times t to the 0th power? We have the same base t, so we can add the exponents, and 2 plus 0 is equal to 2. So t to the second power times t to the 0th power is equal to t to the second power. One way to check this is by using what we know about powers of 0. Anything raised to the 0th power is 1, so t to the power of 0 is the same as 1. If you multiply t squared by 1, you get t squared. Let's try another. What is n to the second power times n? We know that n by itself is also the same as n to the first power, and since we have the same bases, we can use the adding exponents method. 2 plus 1 is equal to 3, so n to the second power times n to the first power is equal to n to the third power. Let's try another. Z to the negative 55th power times z to the 86th power is what? So, we have the same base z, so let's add negative 55 plus 86, which gives us 31. So z to the negative 55th power times z to the 86th power is equal to z to the 31st power. Let's try another problem. What is a to the negative 4th power times a to the negative 9th power? We have the same base a, and negative 4 plus negative 9 is equal to negative 13. So a to the negative 4th power times a to the negative 9th power is equal to a to the negative 13th power. But what if we would like to express the answer using a positive exponent? Well, a to the negative 4th power is 1 over a to the 4th power, and a to the negative 9th power is 1 over a to the 9th power. Using what we know about multiplying fractions, we can multiply this fraction together. 1 times 1 is 1, and a to the 4th power times a to the 9th power is a to the 4 plus 9, which is a to the 13th power. So expressing the answer to this problem using a positive exponent would be 1 over a to the 13th power. Let's do another. X to the third power, y to the 4th power, times x to the negative 2nd power, y to the 6th power. What does that equal? Well, we have to acknowledge that we are multiplying all of these factors together. And using the commutative property of multiplication, we can change the order of the factors because the product is still going to stay the same. But now we've grouped the powers with the same base together, so we can answer two separate problems and then combine them. Do you see them? We have x to the third power times x to the negative 2nd power, and y to the 4th power times y to the 6th power. So 3 plus negative 2 is 1, and 4 plus 6 is 10. So now our problem is x to the first power times y to the 10th power, but these powers do not have the same base. So we're simply going to join them together. X to the first power is the same thing as x, and then we join it with y to the 10th power. So x to the third power y to the 4th power times x to the negative 2nd power y to the 6th power is equal to xy to the 10th power. You're a pro.